Dear students, now I am going to talk about the biomass cogeneration for the subject renewable energy sources. In biomass cogeneration, especially in the application of cogeneration in rice mill. First, we know what is like cogeneration. So here the cogeneration is nothing but the that is defined as a sequential generation of two different forms of useful energy. So from a process, we are getting a two forms of energy. That forms of energy is nothing but the heat and power. That is, we are getting a heat energy and then getting power. That means mechanical or electrical energy. So this cogeneration is also called as that is called as a combined heat and power generation from a single primary source of energy from a single source. So we are getting a input source that is a single input source. So from a single input source, we are getting a two forms of energy. One is nothing but that is called as a heat. The next one is nothing but power. So we are here. We do not need to have a two types of sources for generating heat and power. From a single source, we are getting a two forms of output energy. That is heat and power. It is called as a combined heat and power energy from a primary source. Typically, the forms of energy is a mechanical energy and thermal energy. So heat energy we call as that is called as a thermal energy. Here the power we call it as mechanical energy. Here the mechanical energy is again put into the generator to produce electrical energy. So the basic output form of energy is thermal energy and mechanical energy. Okay. Here the mechanical energy is used to drive alternator for producing electricity. Thermal energy can be used either for direct or process applications for the producing steam. Here, the heat energy that is particularly used for process that is called industrial process. It's form of a heating or soaking or drying. Many number of process that is used by means of steam. In a textile industry, that is used for drying. In a paper industry, used for drying. And rice mill it is for soaking and parboiling. In sugarcane industry, it is used for preparation of sugar. And then second form is the mechanical energy, which is fed into the alternative producer that is called as a electrical energy. This electrical energy is used to run the electrical equipments such as generators, pumps, compressor, fans, blowers, and etc. So from a single source, we are getting two forms of energy, heat and power. Heat is used to for the process equipments like drying, soaking, and boiling. And then second form is power. That power is used that is fed into the generator. Then generator will generate electricity that is used to run the fans, compressors, blowers, and etc. Okay. Then here the third point, cogeneration in India excluding sugar industry because then mostly the cogeneration employed in a sugar industry. So in a sugar can industry, the waste material from the sugar cane is bagasse. Bagasse is used as the fuel for the boiler. Then boiler produces steam. So some part of steam. So here in the sugarcane industry, there is a bagasse. You all know about the bagasse that is a waste from the sugarcane. So bagasse used as there is a fuel in sugarcane industry. This fuel is given to the that boiler. Boiler can produce as a steam. Boiler can produce as a steam. That steam is used for two purposes. One is nothing but that is called as a process applications for preparation of that is a sugar cane preparation. Next, that form of mechanical energy, it is hit into the turbine. Mechanical energy hit into the turbine. From the turbine, we are getting a generator, passed into the generator. In generator, we are getting electric energy. So that electric energy is used to run the fans, compressors, blowers, and etc. So this is the cogeneration process available in the sugarcane industry. Here the waste, what is in the process, sugarcane process, we are getting that is a waste. So that waste is nothing but bagasse. Then bagasse is again bagasse, the waste is fed as a fuel. From the fuel, we are getting power. So waste to energy. Some part of waste is again used as a fuel for converting energy. So that is called as a cogeneration. So Susan, uh, why we move to the cogeneration? In the figure, in the following figure, so 100 percentage of fuel is given, we are getting 36 percentage of electricity. So that is efficiency is equal to that is 36 divided by, that is output by input, that is 36 by 100. We can get some part of efficiency. Okay. Then some other case, sorry, here it is called as that is a 36%. Here, this is for electricity generation. And second, 100 percentage or 100 kg of fuel that is used to produce 80 percentage of heat. Here the efficiency is equal to 80 by 100. So in a case of sugarcane industry, consider. So for running the components like a turbine, sorry, fans, compressor, blower, and etc., we need electricity. From the fuel, we are getting 36 percentage. And for sugarcane processes, for converting raw sugar to white sugar, some steam is required. So for that steam, we are generating a steam from a boiler. Here, generating the steam from a boiler. That steam, the efficiency may be that is 80 percentage. So this process can done in separate ways. This process are done in separate ways. But if you move with the cogeneration system, cogeneration is nothing but the combined heat and power. So there is a combined heat and power. That is CHP already studied. In a CHP, in a cogeneration, 100 kg of the fuel is given. We are getting a 30 percentage of electricity and 50 percentage of heat. So this is used for process equipment. This electricity is used to run the fans, blowers, and compressor, and etc. Finally, we are getting that is 85. That is 85 divided by 100. We are getting 85 percent. Here, the cumulatively we can get the energy. 36 plus 80 by 200. We are getting so 58 percent. So compare this. One is 58. Then another one is 85. So this is for individual process. So this 85 is for cogeneration process. So what type of process we generally prefer? 58 or 85? 85 because 85 is the maximum efficiency. So we move with the cogeneration. Okay. Here in the cogeneration, we given a fuel because in a cogeneration we given a fuel. In that fuel, what are the waste that produced after the processing that is again fed into the that we are getting fuel. So that's why the amount of fuel is reduced. You're also producing 3680, you're also 3050 for same amount of output, but the input is very low because it's 100 percentage. Why? Because the waste from the process is fed into a fuel, so that's why fuel gets reduced. If gets reduced, that input gets reduced. So input gets reduced, the efficiency is that is going to be increased. So that is a benefit of cogeneration. So you come to this point, this system here. Conventional power plant. In a conventional power plant, there is a we are getting a 100 percentage as input as a fuel. We are getting electricity as a 30 or 40 percentage in conventional power generation system. It's a coal-based fire system. So remaining heat is goes to the atmosphere in terms of condenser, cooling tower, or through air and etc. But in the combined heat and power plant, that is called as cogeneration plant. We already told the combined heat and plant is nothing as a cogeneration. In a cogeneration, energy input is 100 percentage. Here we are getting the energy that is electrical and heat. That is called as electrical energy. This is the electrical energy. This one is a heat energy. So combined electrical and heat energy, we are getting energy as a 90. So the green color shows the 90% that is useful form of energy. Here the green color shows the 40% useful form of energy. So the red color form of energy is a waste energy that is moved to the atmosphere. Here in a process of cogeneration, the red color is minimized. There is wastage is minimized. So if wastage is minimized, we are getting a higher output. Okay. So in this slide, I can brief about the normal power generation and combined heat and power generation. Here it is in the terms of boiler. In boiler, in all cases of power generation, we use a boiler. In a boiler, we given a fuel as a input. So finally, we are getting that as in a boiler, the output is nothing but steam, high pressure steam. Then high pressure steam is run into the turbine. We are getting some mechanical energy. In the turbine, we are getting mechanical energy. So the mechanical energy is coupled with what? Generator. We are getting some electrical energy. Then this is called as a turbine. Already there is a turbine. This is a gas turbine, steam turbine. From the turbine, here the unwound then after the producing mechanism steam, it moves to the what? Another device is that is called as a condenser. So condenser is a device that is used for cool down the steam and converting into, here it is the vapor form of steam. Then vapor form of steam is converted into, that is a liquid form of steam in the condenser, and then again it is fed into the boiler with the help of pump. Here pump energy is given. Okay, so in the condenser we have some other system that is used to cool the steam. For converting vapor into liquid, we use some other water that is given, and it is used to take a heat from the vapor. Then vapor is converted to liquid, that is called as a cold water. It is a hot water. So that hot water is going to what? That is called as a cooling tower. In a cooling tower, hot water is, when hot water is moved to the cooling tower, it is sprayed. Then the hot water lost the heat to the atmosphere, and then again it cooled and it make into the this circuit. So this device is called as, that is a cooling water. It's a cooling tower. So this is the normal generation, normal conventional power generation. Then here in a cogeneration, what does this mean? The same device, that is a boiler. Then boiler we are producing, that is steam. The steam is used to run the turbine. Run the turbine from here, the generator, we are getting electrical energy. From the turbine, the waste steam, after the expansion of process in the turbine, steam again it moves to the process applications, or some amount of steam that is taken out from the turbine. So some portion of steam goes to the mechanical power. Here the 100 kg of steam is coming there. In the 100 kg of steam, 60% kg of steam that moves to the run the electric, produce electrical energy, and 40% of steam that is for process applications. Here the process applications is nothing but the drying, soaking, parabol. Then what are the processes that involved in industry that requires a steam? That is a process. So these two steam then moves to the process, like that is called as a drying, soaking. After that, this steam that is purified, then the vapor form of steam is converted into liquid during the process. Then this is a purified and again fed into the boiler. So during the process applications, so during the some process applications, just like in the, if you consider this is a rice mill, the process is nothing but there is a rice mill. In a rice mill, we are getting input as there is a paddy. After we are getting output as a two, one is nothing but there is a rice we are getting as output. The next one is a rice husk. The rice husk is capable of burning because it is one of the biomass. This rice husk is fed into the fuel for, that is boiler. So there is no conventional fuel is used. So waste from the process industry is again fed into the fuel for the boiler. From the boiler we can generate a steam. This is similar for a sugarcane industry, as I already told. In boiler, steam is produced. Steam is used to run the generator, which produce electrical energy. After that, it is a sugarcane industry. We have the waste. Two types of products we are getting. One is the, in the sugarcane industry, one is the sugar. Then waste is nothing but bagasse. So this bagasse is again fed into the boiler for fuel. So in a paper industry, we are having a waste paper pulp. In a distiller industries, we are having some other biomass based wastes. So what are the wastes that produce in the process industry that is fed into the fuel for the boiler? Boiler can run with the fuel, particular fuel. So here the dependency of the conventional fuel like a coal or any other form of fuel is greatly reduced. Okay, so from the waste we can run the boiler and produce a steam. That steam is used to generate electrical energy as well as for the process applications. We have a dual benefit. Okay, so this is the difference between, there is a conventional power. This is called as a conventional power generation. This is called as a cogeneration, or otherwise it is called as a combined heat and power generation. Conventional power generation. Okay. Now, now we are more detailedly in the cogeneration in a rice mill. So in the point, in a rice production from the paddy has undergone the changes from traditional soaking. So note it down. In a previous years or previous decades, we have traditional soaking and drying that can be soaked with water to remove the impurities and then dried in the sunlight. But in a modern method of parboiling at a higher temperature. In a modern rice mill, you already hear about this modern rice mill plant. In a modern rice mill plant, the paddy that is already boiled at some temperature before it converted into a rice. So here, because of it's a parboiling. Here, notice this parboiling. It is a rice. Parboiling is a process that involves a partial cooking of the rice, and it is husked by soaking, steaming, and drying. With the help of soaking, that is mixed with steam and remove the impurities and the paddies and etc. And steaming is nothing but mixed with the steam for some maintaining some temperature for boiling. And next one is a drying. Drying with the help of a steam also. If you move with the parboiling when compared to the traditional soaking and drying, it requires very much time and it is a cost effective. So that's why modern rice mills are equipped with the parboiling. Then it results in increased productivity of a husk and quality of rice. Husk produced is effectively utilized for steam production, which is used for the process and power generation. As I already told, so the rice is used to run the boiler, which is a fuel. So because why rice is whether it is a fuel or not, the character rice is a fuel as given the table below. In the table, rice is having a carbon 34.2 and 36.4, hydrogen and nitrogen, oxygen, water, and ash. These are the composition of a rice gas. Already know ultimate analysis. In ultimate analysis, you are getting the carbon, hydrogen, and CHNO test. But the calorific value of rice gas is nearly to 2,100 to 3,300 kilocalorie per kilogram. If you wanted to convert it into kilojoule, because 3355 into that is a 4.18, we are getting almost in almost which is equal to 3355 into 4.18. We are getting 14,000, almost approximately 14,000 kilojoule per kilogram. This is the calorific value of that is a rice husk. And another one drawback is the rice husk is difficult to control because it is a silica-cellulose structure. Already you know the silica is the substance which can damage the burning system in a boiler, which can the silica presence of silica is the more dangerous because one thing it can forms a it forms a slag inside the boiler which prevents the heat transfer. So that's why. So to avoid that, three-stage bed combustion boiler is used to ensure the complete combustion of firing is balanced between the buoyancy and gravitational force because rice is having a less density that can move that moves to the buoyancy and no fuel is that is flow under the gravity. Because of buoyancy that can move up, because of gravity it can move down. So we have to balance between the up and downward motion of the fuel. Fluidized bed boiler is used because in a fluidized bed boiler, in FBC boiler, the fuel should be in the suspension while during the burning. Okay, if the silica in the presence of silica in the fuel results in the deposition of slag in the boiler walls, which results in the minimization of heat transfer. So that's why FBC is preferable in a case of rice boiler. Okay, here the next steam from the boiler come to the turbine. Here one thing you know, before that the turbine used in the cogeneration is a back pressure turbine. So what is a back pressure turbine? Back pressure turbine is a type of steam turbine that converts the excess steam into a mechanical energy uh, which can be used to power generators, fans and fan compressor because this is a turbine. So some steam that coming here, some part of steam is goes to there is a process. Remaining is goes to mechanical energy and then converted into that is electrical energy. This is a generator. So here note that time converts the excess steam. So if it is 100 kg of steam is coming, so 60% is used as a process, remaining 40% goes to the generate electricity that is used to run the pumps, fans, compressors. That is called as a back pressure turbine. So here the back pressure turbine is employed in the rice husk boiler. Uh, Here the steam from the boiler is 600 kilogram per hour and coupled with 350 kilowatt of electric generator, which the having a pressure is 32 atmosphere at 400 degrees Celsius. Now we can move into the diagram. Here this is a boiler. Already know boiler. In the boiler, the fuel that is nothing but that is called as after drying. Uh, After drying in a rice mill, the fuel line is this is the fuel line. This is the fuel line. That is our rice husk. So if fuel husk is given as a fuel, then it produces electricity. So it produces steam. That is steam is moving to the turbine. In the turbine, some portion that is required to generate, some portion is required to generate. That is a power, electrical energy. Some portion is required to generate electrical energy, and that is the remaining portion that can moves to the process application. These three are the process applications in the rice mill. So first one is soaking. Soaking is the mixing of paddy with steam. Next one is a parboiling. It is a boiling a paddy at a higher temperature. Then after parboiling, that is a drying. So this is the first process in the process. There is a second process, then third process. Then after the third process, the paddy that moves into the rice mill for grinding purpose. The grinding purpose, we are getting the boiled and ground rice. The waste is husk. So the violet color indicates the paddy preparation process. So rice preparation process from the paddy. Paddy is the input, soaking, parboiling, drying, and then it moves to the grinding. The rice mill, that is a grinding process. In a grinding process, rice came out and huskies came on another side. The husk is used as a fuel. This is the process of then rice. The rice mill. So here, then after the soaking, paraboiling, and drying, the steam loses the heat and becomes a water. Then these three here after paraboiling, the impure water is moved to the water treatment plant. Then the remaining water, the remaining steam, and then after drying the remaining steam that moves to the one part of steam that is moves to the what that is air preheater. In an air preheater, air is used to heat some degree Celsius for better combustion. Here, heating is not done by external fire. Here, the heating is done by the water, the heat that available in the steam. That steam is used to heat the air preheater. So here, the air is heated with the waste source. So that is one benefit. Then another steam from the drying unit again it moves to the deaerator. So what is deaerator? So in a deaerator is a device that is mainly used for deaerator is a device that is used for removal of dissolved gases like oxygen from a liquid. So it is used to remove the dissolved gases. Then after that, the steam and what are the steam? The steam that is moved to the water for the feeder. Here in the deaerator, so the 3000 kilogram per hour of steam after the process coming, again we are giving 3600 kilogram of water is given as a makeup water, that is called as a feed water to compensate the because compensate that here the 6000 is kilogram per hour of steam going is going here some process in 6000 3000 is again fed into the boiler. So where we go for remaining so remaining 3000 we are giving a what fresh water. So we're giving the fresh water is a 3000 kilogram per hour. So this water is called as a makeup water. This is a makeup water. So in a 6000 kilogram per hour, 3000 is reused and the remaining 2000 that can be 2000 and here also 1000. This 1000 and 2000 are moved to the water treatment for processing of removal of impurities and again it fed back to the boiler purpose. So here the one water treatment is another one water treatment plant is there. Here the impurities like a paddy, dust and other thing are present that is removed and we're getting a purified water and the purified water is given as a makeup water. Okay. So deaerator make a middle here. So the water can move to the boiler and produce a steam. Here in the air preheater, air is initially heated to the waste stream and then it moves to the another one air heater. Then again it fit into the boiler at a temperature of 80 degrees Celsius. If it is given to the atmosphere, the air temperature is say 30 degrees Celsius. 30 degrees Celsius air is converted to 80 degrees Celsius with the help of one waste heat recovery device that is called as air preheater. Okay, so these are the overall view of the cogeneration plant in a rice mill. It has a plant that can run with the fuel as a paddy husk fired FBC boiler. So some part is used for generating power, some part is used for making the process applications. So after the process application, some part of steam is given as a input as a water and some is moved to the waste treatment plant. Okay. Similarly, this case is also exists in the sugarcane industry. In the sugarcane industry, instead of soaking, parboiling, and drying, we have some other process. In it is the input is that is called as a raw sugarcane. That is the input. Finally, we are getting output after sugarcane is that is called as a white sugar. Here the waste is instead of husk, we are waste is bagasse. So the process name is different. The structure is same. The process name is different. The input is a sugarcane. Output is a white sugar. The waste is a bagasse. Bagasse is given as an input to the fuel. In similarly, this is similar in the case of paper industry. In the paper industry, we have some process here. It is to be paper pulp. Paper pulp is given. So paper pulp, we are getting a final output is nothing but white paper. Then waste is some form of pulp. That pulp is given as pulp is again it is fed into a fuel for boiler. So the process is different from case to cases, but the working principle is similar. Okay. This things that is soaking, parallel drying. This is explained in the previous slide. This is point the deaerator supplies 6,000 kilogram per hour water to boiler. That is a 3,000 kilogram is from the drying process, and remaining that can be given in the makeup water. Then air is used to heat the temperature of air up to 80 degrees Celsius. The last point, 50 ton per batch capacity right mill generated 350 kilowatt of power. So per batch it can generate 50 ton means almost into 50, which is equal to 50,000 kilogram per batch, generated 350 kilowatt of power from rice husk, which is normally dumped as a wastage. So what are the waste produced in the paddy processing unit, that is rice husk, which is used to generate 350 kilowatt power, and steam with having process applications. So at present, 47% of rice is used as energy storage. Okay. Then we finally move on to the advantages of cogeneration, biomass cogeneration. One is a higher efficiency of plant. Already we know that is efficiency of plant is 85 in a cogeneration, but this single plant efficiency is 58%. So we're getting a better efficiency. Then higher yield, reduction of energy waste is greatly reduced because waste energy is given as a fuel for boiler. So reduction of greenhouse gas emission because the boiler is running with the biomass. So CO2 level is very low because the CO2 produced by the biomass burning is absorbed by the biomass plant. So CO2 emission to the atmosphere is very low. So reduce the base load electricity. Base load means we are not depending on the electricity from the conventional source. We are generate electricity from the cogeneration process itself. So base load electricity supply is reduced. Reduce the primary energy cost because waste as a fuel, the energy cost is reduced, helping reducing carbon footprints. Because if we run the boiler with the conventional coal-based fuel, it can increase the carbon footprints. But if you run with the biomass, the carbon footprint is reduced. Oh, okay. Another side we are having is some drawbacks. What are the drawbacks? One is called that is environmental impact. So we are not continuously run with the biomass plant because it is that may results in the deforestation because continuously running biomass leads to cut the plants and some other parts. There is a deforestation. Next one is the cost. Cost can be widely depending on the type of biomass used. So if in case of bagasse or rice husk, this is produced from it. If you use some other biomass, it can require a higher amount of cost. So just like wood or some other biomass sources. The installation of cogeneration or combined heat and power requires large of a front capital investments. Capital investment is required because it requires a some of additional machineries. So maintenance is somewhat difficult when compared to the traditional plants because it has a more parts. So maintenance is required, and it is involved in the process application system. So if you move the process, it deals with them impurities and purification process. So that's why higher maintenance is required, and many more modern buildings are needed for cooling as well as heating. So for the waste treatment plants and then air preheating some assemblies, it requires additional area and additional plants. So that increase the cost of the plant also. So this is about the drawbacks of cogeneration plants. Okay, thank you. I hope you can understand very well about the cogeneration from a biomass. So this is mainly based with the milk cogeneration. Anyway, I have touched with the sugarcane based cogeneration and paper industry based cogeneration also. The difference is this process only, but the remaining principle is same. The waste, if you given input as a here, you are getting output as a here. The waste is run used to run the boiler. Okay, this for this process we can run the steam that is coming up from the boiler. Okay, thank you. If you have any queries or any feedback related to the videos, can give in the comments box. Okay, thank you.